We have inverex XP series. We have no LCD in this, and I am not wearing a gloves because I need to zoom in and zoom out with fingers. So when I wear a gloves, then I cannot zoom in and zoom out. Let's get started. Providing the operating power with limited current. First of all, we have a nice is in cooling pan. Okay. So first we need to remove the screws. And I provide a more light for good view. And now I need to check the response with this light and zoom in and zoom out for best view. And after that I need to get a result. We have the required size screws on this, and the screw is not opening. Not opening. This is the unqualified person works. We need to wear gloves. Okay. We are opening. Now we need to apply a force because we don't have any chance to open this screw because it's okay. Now you can remove this easily from this side, and as you can see here we have a broken area because the people are also removing from this side, and this is not the good method. And now we have here a screw, and a screw not opening, so first we need to apply force to separate and rotate the screw anti-clockwise. Okay, then we can remove the screw, and after that you can remove from here. Okay, this side is too broken because the people are opening from this side, and this side is not good to open this. You need to remove like this. Not required screw. Here we have output neutral, and here we have output line. Okay, first of all we have issue in our cooling fan, and first I need to clean this. But I have a little energy and my lithium battery, when I start an air blower, so it's possible the inverter is shut down. Because yesterday I forget the main input breaker and I consume all the power yesterday, and today we have no electricity, utility electricity, because we have the fault in the grid. So now I need to use little power. Okay, now I need to little zoom in. Okay, because I provide some more light for good video. I have a call. Hello. Walaikum salam. How are you? Come here. من बिजली यार बिजली नشता मसला ده زه دا د وایم ښه مثلا لږ د بیټرۍ پاور هم کم دی او بېګا زموږ د بیټرۍ چارج ته لګولی شو یا پرون څه ټیک نه وم ناست وم هسې ناست وم او مې ټوله بیټرۍ استعمال کړې وه یاد دی راته صحیح ده چې لږ بجلي پاور راشي sorry for that, and I need to receive a call from the customer. So first we have issue in our cooling fan, so first I need to replace cooling fan, and after that I need to check what the fault, because we have no LCD in this inverter, so we cannot detect the fault. Okay. This is the star hexa screws, and you can make this. I make this for this. It's a little hard to remove. What the reason company installed this screw on this? Okay, first I need to replace this cooling fan. Okay, I have just for temporary check. Okay, first I need to install this cooling fan temporary, and this is the very old model. Okay, now I need to check this. We have a fault in inverter, so we need to remove the board. We have an issue in cooling fan, but we have issue in our main board. So first I need to remove this LED panel strip, and this is the switch panel strip, and after that I need to remove this negative and positive from here, but first we need to remove this. This is per narrow wide. Okay, also some people are forget this is per narrow wide, and the bottom in this circuit we have per 10 amps and 20 amps selector. this. It's okay. Here we have part 10 and 20 amps selector switch. Okay, and after that we need to remove the screw, but we have not a screw on this. And this is the unqualified works. First you need to push this hook. Okay, and we need to have here one more hook, but here we have not. Okay, I need to remove the input neutral first, and this is the input line. Okay, finally I remove the control board, the main board. And this is little difficult to work in this board, so I am trying to clean this. If I lost the power, I have a data in my mobile phones. Okay, down your multimedia volume. Okay, I clean the board from dust with the air blower. Okay, now I need to little zoom in for good view. It's okay. It's okay. First up, all we need to check our DC to DC boost section. And how you can check DC to DC boost section, set your multimeter on continuity mode. Okay, and this is the MOSFET pin number 1 gate, and this is the pin number 2 drain, and this is the pin number 3 source again. Okay, because I miss the view. Pin number 1 gate, 2 drain, 3 source. Okay, keep your multimeter negative probe on the pin number 2 drain and positive on the pin number 3 source. Wait for discharge the capacitor. First I need to discharge the capacitors with some resistance. Okay, now I need to check drain pin 2 source. Wait for it. Okay, wait for discharging the capacitors. Discontinuity is true. Okay, now you need to check, keep the multimeter negative on the pin number 1 gate. Okay, and here we need to have a 600 plus a continuity. Okay, this continuity is true. Okay, and now we need to check this. Okay, this is okay. Now we need to check This continuity is true, and now you need to check this, and this continuity is true, not that. Okay, if you have this continuity, it's mean your control drive circuit of this DC to DC boost section MOSFETs is okay. And where this continuity coming from, if you are interested, so I need to draw some schematics. Okay, this continuity has come from, this is the SG3525 PWM modulator bar, this DC to DC boost section, and this has been 1 2 3 4 5 6 7 8. Okay, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Okay, and this is the MOSFETs. Okay, one side, and this is another side. Okay, and this is the battery negative. Okay, and this is the battery positive. Okay, so this is the MOSFET pin 1 gate, 2 drain, 3 source. Okay, same like this, 1 gate, 2 drain, 3 source. Okay, this source is already connected with this battery negative. Okay, with this battery negative, and this source is connected with same this battery negative. Now this is the pin number 12 of this PWM modulator SG3525. Okay, this pin number 12 is connected with this battery negative. Okay, so here I am connecting. Okay, and the positive are connected with isolated power supply, but the pin number 12 is connected with this MOSFET source pin. Okay, and when your PWM modulator is okay, so I am guiding more you. Okay, this continuity is coming from here like this. This pin number 12 is connected with a battery negative and with this source. Okay, and now I need to keep this here. Okay, now or this pin number 12, 9, 10, 11, 12. Okay, this pin number 12 is connect with this negative. Okay, and when you keep the positive pin on the source, okay, so this is the source pin and this is connected with this pin number 12, so I'm keeping here 9, 10, 11, 12. Okay, this is the pin number 12, and when you connect this on pin number 1 gate, so the gate is connected. First I need to draw this full schematics for understanding you. The pin number 11 is connected with one MOSFET gates with some resistance, 10 ohm resistance. Okay, and the pin number 14 is connected with this another MOSFET gate with some resistance 10 ohm. Okay, and when you keep the positive pin on the pin this source, so this pin is connected with this 9, 10, 11, 12. It's connected with this pin number 12, and now our output A and output B is pin number 11 and pin number 14. Okay, when you keep this probe on this gate, it's mean you keep the multimeter negative on this pin number 14. So I am keeping here, this is the 12, 13, 14. As you can see here we have 643 ohm continuity. First I need to set this again 9, 10, 11, 12. Okay, and when you keep on one side, this is the pin number 14. Here we have 643 ohm resistance, and when you keep on this another side, I'm keeping still on the pin number 12 positive. Okay, 9, 10, 11, 12. Okay, and when you keep on this MOSFET side, okay, so this is connected with this pin number 11, 9, 10, 11. As you can see here we have again 642 ohms. Okay, and if you are checking this modulator full checking with multimeter, so you need after this to keep the multimeter negative probe on the pin number 13. Okay, 9, 10, 11, 12, 13. This is the pin number 13. You need to keep the negative on the pin number 13, and here we need to some extra resistance. Okay, from pin number 12. As you can see here we have 809 ohm resistance. Okay, and after that you need to check the pin number 11. We need to have same resistance on pin number 11, 9, 10, 11. As you can see here we have 809 ohm resistance. It's mean or this modulator is okay. But why you are not find this positive? Because just negative connected with the MOSFET source pin. Okay, so this is the true continuity. Okay, and now we need to check the DC to AC converting section area. Okay, and how you can check: set your multimeter on continuity mode, and this is the pin number 1 gate to drain, 3 source. Keep the negative on the pin number 2 drain and positive on the source. This MOSFET resistance is okay, true resistance. Here we have 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 true resistance. Or this 5 MOSFETs is okay. Then why getting in the fault? So after that we need to check the charging MOSFET. Pin number 2 drain, 3 source, true continuity. After that you need to keep the negative on pin gate, true continuity, reverse the polarity. Okay, this continuity is not good. For this gate we need to check this. I think we have issue in our charging section, and this charging section is related with output voltages. Okay, and some person work in this. I need to check first we need to remove the gate resistor from here for easy repairing to check the MOSFET. Okay, to confirm this we have a short resistance with gate. Okay, so this is the AC method. You need to remove this 100 ohm resistor. Okay. Now you have just the MOSFET. Okay, no any continuity of PWM modulator. Now I'm checking the source pin continuity, source drain to source, and here we have no any continuity from modulator. Now I need to reverse the polarity, and here we have 1.3 and Y. Okay. I think we need to remove the MOSFET because here we have 1.3. It's mean 13 1300 ohms resistance. I think. Reverse the polarity. No any ohm. This is in the continuity. I think this is the diode. First I need to check this diode. This resistance is okay. Now I need to check this. No any we have, but we have in the continuity mode. So I need to remove this MOSFET. This is not the good method to remove. It's okay. Now I need to remove this MOSFET and check. Then open circuit. Open circuit. It's okay. First I need to remove this. Get pin broken. Old MOSFETs. Okay, but I need to check now the continuity. Okay, we have no continuity. Okay, we have a continuity in our PWM system, but I removed the gate MOSFET. Then why we have? It means I need to remove this diode. Okay. I need to check. Okay. Now we have no any continuity. Now I need to check this diode and this open circuit. Why? The diode is true, the resistance is true, and after that we need to check this PWM modulator of this charging section. Here we have, okay, this UC3843 as operating this MOSFETs. Okay, so first we need to check this like previous modulator method. Okay, So this is the pin number 1 of this modulator. 2, 3, 4, 5. First you need to keep your positive on the pin number 5 of this UC3843 and negative on the pin number 7. Here we have this continuity is not good. You need to have 600 plus, and after that you need to reverse the polarity. On the reverse polarity we have a continue. After that you need to keep the negative again on the pin number 5, and you need to keep the multimeter negative on the pin number 6. Okay, here we have 642 ohm resistance, and when you keep the negative on the pin number 7, and after that you keep the pin number 6, so here we need to have some ohm more than from this. Okay, 709, so then 5. Okay, first we need to check the PWM from this modulator. First I need to install this resistor and diode again, and after that I need to check the PWM modulation of this modulator, and how you can check this modulation to operate this MOSFET. First I need to clean this. And install a gate drive resistor and diode. And now I need to check this. Okay, first I need to check this for investigation. No any continuity we have. No any continuity we have. And why? We need to trace this issue. Okay. First I need to remove this alt solder from here. Install the resistor and diode again. For PWM modulation, I need to just install the resistor. Okay. After that, we need to install a diode. Okay. Okay, now I need to check the continuity again. Positive. This continuity is true, but this is not true. But I need to confirm this. Okay, I need to confirm. So how you can confirm? First you need to install cooling fan or feedback. Okay, to run your inverter properly. Okay, and after that you need to have this switch like this. You need to make a switch like this for easy turn on and off. It's okay. Now I need to provide power. Okay. And keep the multimeter and set your multimeter on DC voltages, and after that you need to keep the negative on the source pin number 3 and the positive on the gate pin number 1. Okay, and when you turn on the inverter, why the inverter is not turning on? I think I apply reverse polarity. It's okay. Stand by. No. Okay. Now I need to turn on check inverter. Okay. Positive on the pin number 1, get negative on the pin number 3 source. Okay, I need to check. Okay. We have some voltages. Okay, I need to check with oscilloscope. Okay, I think this issue is little hard. I think I need to check with oscilloscope. So I need to keep the oscilloscope on here. Now I need to provide power. It's okay. Now we need to check the frequency and duty cycles with oscilloscope. So keep the negative on the pin number 3 source and positive pin number 1 gate. And after that you need to turn on. Okay, first I need to provide again power supply negative. Okay, turn on. Okay, our PWM modulator is okay, and we have a PWM modulation from this. So now I need to install a MOSFET, a true MOSFET here. What the MOSFET person install? W129K90Z. Okay. In the inverter mode, you need to have this modulation, okay? And the charging is too, but this is the requirement of this board. You need to have special when you have a LCD in your board, so also you have to fault 3, okay? And this area is related with fault 3. Now I need to just install the new N-channel MOSFET Toshiba K3878. Okay, give me just little time. I need to get my tablets. Okay, now I need to install. At first time I am looking this continuity, but I need to trace this. Why the continuity is different. Okay, cut the extra pins. Solder this first. After that I need to clean, but first I need to check this inverter. Positive, negative. No, we have again issue. Okay, so now we need to check this MOSFET gate drive. Okay, first we need to check, and one special thing I am sharing you because you are watching me. Okay, so I need to share some special tricks with those people who are watching my long live videos. Okay, first I need to solder my this analog multimeter, and this is the one thing we have just a special quality in this we have not in this fluke. Okay, and the thing is that first set this meter on AC voltages. Okay, this is the special trick to know about the fault 3 related, and turn on the inverter. Okay, I am sharing with you the method, and look at. Okay, in this side we have a little voltages. Okay, and now you need to reverse the polarity of your analog multimeter. Okay, and after that you need to check its mean or voltage is not DC. If you have one side high voltages, okay, here we have, and if you reverse the polarity, I think this is the DC, because for one side we have a little, okay, and for other side we have high voltages. Look at again, look at, for this side we have high voltages, and when I reverse the probes we have a low voltages. It's mean this voltage is not pure AC. It's mean, or this 4 drive is not okay, not true. So now we need to work on our this drive. Okay, and after that we need to have a true continuity of this N channel MOSFET. But first I need to install this diode again, and I need to check the person install same number of different, but I need to install new one because the doubts is not good. Unknown person work in this, and finally he cannot repair this, and now I need to repair. Okay, so first I am installing just this diode here, and after that I am sharing the method how you can troubleshoot this 4 drive system. Okay. Now listen, okay, carefully. First I need to provide some tape for this buzzer because this is the very bad sound. First I need to get some piece of tape, okay, and close this buzzer for temporary. Okay, and now I need to attach the power, and I need to set the direction of MOSFETs like 1, 2, 3, left 1, 2, 3, right. Okay, we have a pin number 3 on right side. Okay, so first I need to provide power. Here we have positive, and here we have negative. Okay, so if you have, first I need to set the meter on the, sorry, set your multimeter. If you have auto, so you need to set your multimeter on manual range, okay, not auto range, because this multimeter cannot measure the voltages in this milliseconds, okay, because this is dependent on very high software. You need to set on manual range, and after that you need to keep the multimeter negative on the pin number 3 source. I am starting from this MOSFET number 1, okay, and after that turn on the inverter. First keep the negative on the source, okay, and after that turn on and quickly connect with the gate. Okay, we have some voltages, but I need to set my multimeter on maximum. That's okay. Now I need to turn on. I'm trying on this. Okay, okay, we have 4.96 voltages to operate this MOSFET. Yes, okay, now I need to set this again, manual range 60, okay, and maximum, okay. Oh, quick read, man. Now I need to turn on again because my switch was on. Now I need to first keep the negative on the source and turn on, and quick keep on the gate. Okay, we have 4.69. That's okay. Now I need to turn off, connect again, and first I need to keep negative first. Okay, turn on and quick connect with pin 1, but I does the mistake, so I need to turn on again my meter, set the manual range maximum, okay, and now I need to connect again, turn off the switch, connect, negative first connect. This is the third MOSFET. Turn on, quick connect with gate. Okay, we have 1.5 volt on this gate. Okay, now I need to check the 4 number MOSFET. Now I need to set again. This meter cannot set again, okay, and I don't know about this. I have just to off and turn on again and select the manual range and maximum, okay, and turn off. Okay, now first you need to keep on the number 4 MOSFET and turn on, quick connect with gate 1.4, and Y. Now we need to check the gate resistors of this MOSFETs, and I can read this from microcontroller. Okay, from here to microcontroller. Okay, I can trace this fault. First I need to check the gate resistors of these two MOSFETs. We need to have here 220 ohms resistance. Okay, we need to have here, okay, this is connected with this. Okay, this is connected with this. So we need to check the continuity of gate. Sometime I receive the gate continuity. Okay, no any gate continuity we have short. Okay, same continuity. Okay, now we need to check this continuity. 1.9. Okay, no, 1.6. 1.6, same continuity. Now we need to check here a voltage is the one another method we have, and I need to share with you. And this is very easy and successful method to check the drive of this MOSFETs. You need to have a LED. Okay, okay, the electricity is now available, and now you need to have LED, and the LED negative you need to connect with source pin. Okay, of this is 1 2 and this is the third. Connect the LED positive pin with the gate and negative with the source. Okay, now turn on to confirm this voltages. Okay, this is the AC method first file. Now look at the LED. Voltages. Hard drive. Yeah. Okay. So okay, we have. So what the happen we have in this? Okay. Now the turn check the DC voltages on the capacitor. This is the basics. Okay, you can troubleshoot only with this method, not with flukes. Okay, first I need to set to range 600 manual range. Okay, I need to set the polarity. Turn on maximum. Okay, 295. It's okay. We have enough voltage on this. Okay, now I need to check the bridge diode the man thing. This is the bridge rectifier diode. Okay, no continuity, no continuity. Okay, we need to have a MOSFET continuity. It's okay. Then why? And then here our work. Okay, sometime we have okay, we need to check this diodes. This is converting the AC to DC from transformer. It's okay. It's okay. It's okay. It's okay. I think we have an issue in this. This continuity is true. This continuity is not true. So give me some time to think about this. How we can troubleshoot a man who remove everything and install again. For this reason, sometimes we have a get continuity, so first we need to remove this 4 MOSFETs, okay, to check in the open circuit. First I need to remove this MOSFETs. Okay. To remove and check the MOSFET first. My turn. To check my experience or knowledge. Okay. Now I need to check this MOSFETs. Okay. Keep the negative on the pin number 2, positive on 3. True resistance. Apply the positive on the gate. This MOSFET is okay. Internal resistance, apply on the gate. True. Okay. All 4 MOSFETs is okay. Now I need to check this continuity of this. True continuity, bad continuity. Okay. Now I need to remove this M modulator. confirm this continuity. Why we have a low continuity on another side, and here there works, and remove, and here they work, but I need to check. I am not confident on this continuity, so I am removing this modulator from this to troubleshoot this issue. I have a hot air gun, okay, and this is my technique to quick remove and safe remove, like this, okay. Now I need to check this modulator in this open circuit about pin number 5, 7, okay, reverse, no continuity, okay, that's okay. Now I need to check from negative 542 and 700. Now we need to check the new modulator, how much continuity we have. Pin 5, pin 7, 600, okay. Now we need from negative 672 and from positive 725. How much the difference? 71, 50 ohms, okay. Now for this, $768. It's okay. It's okay then. Why? Now I need to check this continuity because I removed the modulator. Now I need to check this continuity. Now we know we don't have any continuity because I removed, and now I need to install a new modulator to find this fault. This is the modulator pins. First I need to remove these solders. And the electricity come just for 5 to 6 minutes, and now again cut. So we have still a fault in our grid. It's hard to clean with this. It's okay. Again, Tom. Okay. Now I need to install this modulator. now my hands is free. Now I need to proper solder this. Okay, now I need to check the continuity again. True continuity. The IC is hot because. Okay, now I need to check this. Now I think we have a different continuity from previous. Okay, I just replace this modulator. Oh, the man install I am sharing with you. This is the UC 3843AL. So okay, now we have a true continuity. Okay, this continuity is true and this continuity is true, and now I need to just install a MOSFET. I remove. Okay, first I need to remove this solder first and install the MOSFETs. Because everything we have true, we need to find the issue where we have I order a good solder sucker, some dash. Okay, remove all the solders, and now I need to replay. Sorry, I am installing the remove MOSFET from this board because we have a true MOSFETs. Okay, because I checked this and I checked with the gate voltages, so it means our MOSFETs is okay. And now I need to check. Okay, straight this. Oh man. It's okay. No any particle we need to have. Okay. I need to set this on this position. Source voltage here, and this is for here. This is here. Man, it's a little difficult to install this. This little screwdriver is very good for me to tighten this type of screws. So, oh man, it's hard to install. It's okay. I need to check. We have still issue. Now I need to check this meter. No. We have still issue. Our output AC or output voltage is not pure AC. Okay, our output voltages is not pure AC voltages. I think this is the over voltages. First I need to set this, check Okay, now I need to check this to hold this voltages, how much voltages we have in output. Maximum, first I need to set in range, manual range 600, and after that max, turn on. Next, for this side we have 57.6, and now we need to reverse the polarity, okay, and off the meter and set again the manual range 600 and set on the maximum, turn on 56. Just cannot read the pure AC and pure DC. We need to troubleshoot this issue, and this is the challenge for me. Okay, first I need to clean it in this area. Okay. And now what we can do for this, I need to check this jumper. Is the person installed properly? And we have here, I have not one resistor, and I need to check on the and there's a na dukaan nyo kung bibinis tiyara o basta na kasi nasyo no. Udah यार नन जमू बिजनेस यार सार ना हो करूँ बा बैटरी चार्ज तो लो के कहो दिया वो बैटरी पड़ल बनो ना से बसा लाइट में बोलो ना मोबाइल में तो चीज़ है ना ये उल्ला सीमेंट तो लगा लो टक शुरू बिया लाड़ा okay. This is my challenge to repair this. Okay, I need to check this resistor. Here we have the R3AX resistor. I need to check with this, and this board is not same with this. This is another board. Area man. very fair. But I need to check these areas. Okay, now I need to remove this jumper and check this where they install and where we need to install. And this is not the method to install like this. First of all, I need to clean this. This is the single area, and when I've lost this line, that here I need to check this. I need to scratch this and I need to provide again green mask. Okay. No. Okay, this line is okay. And after that we need to check this impedance resistor, and we need to check some resistance of this modulator. This is a pin 1, 2, 3, 4, 5. 5 with 3 we need to have 1.8. Okay. And this 1.8 we need to have from this resistor. First I need to receive this code. Hello? Alaikum salam. Hello. Yes, pero mo sudah kam ke sanggen mo to. Ha? कभी कपने वाला होता अक्सर तासिनु मियां हुआ है लिकले बली नु गट ल बजाऊंगा सुतिया हो गए खुदा पाक यूपीएस पदी नु मिस्टर जा पवन मान दिया सॉटा इसके और क्या daer tikte da chide da tikte na ma mega chikdo pagi number aga puran show de padan ne da cha likal le ba number must kari wow واي کې نمبر نه ښکاري دا ټیک ته دې کې څه مسله نشته ښه هلته بس تاسو بیټرۍ کې مسله یې چېرته ښه okay sorry for wait and now I need to check this here we have ampere sense resistors connected with this source and I think here we have first I need to confirm this we need to have a resistance from here with this pin number 3 1.8 kilo ohm that's okay that's done and look at man here we have to check some here we need to have okay this resistance is true and then why I have a doubt in this area because here we have no resistor okay and I have not the schematics and the person who worked this he removed some things and now I am not sure because this is the diode so install the diode add to it's okay true resistance again diode true resistance and here we have add to here we need to have Zener diode okay not a simple diode and he removed the Zener diode from here as you can see he removed this Zener diode from the board because this is the icon or symbol of Zener diode okay and as you can see he installed a A2 simple diode and I think he removed the resistor from here so now here we have some doubts first we need to clear these doubts because the unqualified person work on this and this is the very latest and high technology system if we don't have a one resistor in our board so we cannot detect here we have a signals to drive this MOSFET and here we have a signal to drive this MOSFET then why then motor going into the fault and finally we have a DC voltages on output so first we need to search about this I have a board I was purchased this in scrap and I just remove the relay no any component and I keep for this but this is not the same model so I need to check this area here we have one Zener diode and one resistor connected with this we have a Zener diode so first I need to click like this and after that I need to check Here we have one Zener diode, and here we have 150 ohm resistor, and here we have 240 ohm, 240 ohm, and here we have a M1 Zener diode, M1 Zener diode. I think this is the 12 volt Zener. I need to install here the 12 volt Zener. And is this possible? Some people are giving my exam and he doing this type of work. Also he remove a one component and trying me. They able to troubleshoot this part or not. Why, man? What you can get with this? Why? And if you don't know about the Zener and diode symbol, then why you working on this board? This is the symbol of Zener diode here, right? ZB1X. Then why you install a simple diode? Here now I am installing a 12 volt Zener, but I have a doubt about this component because now I need to check. And for 100% repairing, I need to have this type of board. Okay? This is the basics because we need to have schematics and values. We have still. Okay, now I need to provide this jumper, and after that I need to check this again. But this is the not method. Person install jumper, method is that you need to get a copper thin wire. Okay, and after that you need to pull in this. But first, here we have two bushes and two broken lines. First I need to create a hole in this with thin drill bit. This is not thin. Okay. To this. No, this is not. This is very thin. This is perfect for this. I'm checking on this side. I need we have one. Okay, welcome. Here it's okay. This line was connected with this, and here we have just spalted area, no any connection. It's okay. If I can, it's okay without another board, and if I cannot, so I need to have this type of board, and then water is coming every day for repairing. I am receiving then motors for repairing every day. So first I need to get this type of board. So okay, now I need to install this. And this is the very beautiful work, but if a person work first from me and then water after that, it's very hard for me to repair. This is the method, okay? Repair the lights. And after that I need to provide a green mask. But when I repair this, after that I need to provide a green mask on this area. Okay. I need to check what happened now. I need to install cooling fan, feedback. No. نفتح ولا
UPS आ गया
Come here.
उसके लिए बोल रहा हूँ स्पिन UPS पे
Charge the vesa.
हाँ
बराबर शुरू है मेरा बात. Okay, now I need to check the output voltages. We have a DC output voltages or AC. Not check Steve. Okay. First I need to zoom out to show you this analog meter. You can check the pure AC and DC just with this analog multimeter, okay? I need to check. We have still a DC voltages, it's mean or two MOSFET in theory or two MOSFET is not working. And Here we have 1.5 voltages. First I need to get fewer AC voltages, and after that we need to check high or low voltages. Okay, this is the basics related with this Zener diode. First we need to get a DC voltage. Now I need to check this. Here we have like bridged diode. So first I need to know about this circuit. This is our capacitor negative, and this negative is coming some source. Okay, this negative is connected with this source to convert the DC voltages to AC. Okay, so I can check this when I keep the positive probe on this. Okay, first I need to provide power supply. And after that I need to provide power. So this is our positive. Okay, and when I set all my multimeter on DC voltages, and I keep here and turn on, and after that I need to keep on the drain. Okay, I receive a 280 volts. Okay, and after that I need to check this another MOSFET output. This is another. Okay, these two MOSFETs are in working to provide a negative, and after that I need to keep my multimeter negative here. Okay, and first I need to know about the positive as coming here to this MOSFET, to this MOSFET drain, and after this MOSFET drain I need to have a continuity with this drain. That's okay, that's okay. So I need to keep my positive negative, my negative on this, and I need to get a positive output from this MOSFETs like previous. So first I need to turn on and keep on this source. Oh, okay. And then okay, our positive is coming to this drain, and after this drain we need to keep our no man, why I am confused. Okay, first I keep my multimeter here for negative, and what is this, man? I need to repeat this process. Here we have our capacitor, and this is our capacitor negative. Okay, negative, and this negative is coming to this source and this source. Okay, so we need to get a negative from this MOSFET, so I need to keep the positive probe here. Okay, and negative, after that I need to keep here. Okay, I am getting a voltages, a negative voltages from this to and now I need to get a positive voltages from this, so I need to keep my multimeter on this negative. It's okay, on this negative, and after that I need to keep my multimeter on this. Sorry, first I need to know about we have a positive on drain, so we need to keep our multimeter on source. It's okay. On this source I need to set my multimeter. First I need to manual range 600 and maximum, and after that I need to turn on again. Oh man, that's the mistake. It's okay. On this source, I am receiving just a 62 volts. That's okay. On this source I am receiving, first I need to reset my multimeter. Manual range 600, maximum turn off. On this source I need to receive, okay, it's mean, or this two MOSFET is not working properly. Okay, this is the method. This two positive we are not receiving, so we have NPN and PNP transistor and this little dry cord. This little dry cord, first I need to find the transistors of this MOSFET. Okay, this is our gate drive resistor of this MOSFET. First I need to find the perfect line for this. Okay, this pin number 1 from this side, that's okay, and after that I need to find another. I think this pin number 2, no, 3, no, 4, no, 5. From this side we have pin 1 and pin 5. Okay, for this MOSFET like this we need to have pin number 5, 220 ohm, 1 2 3 4 5. That's okay, confirm pin 5, and for this pin 1, that's okay, 1 and 5 number pins we have for this MOSFETs. So now I need to know about this pin number 1 and pin number 5. Okay, the pin number 1 is here coming. Now I need to check this NPN and PNP transistors. Pin 1 is coming here. This is the diode, true resistance. This is another diode, true resistance. What's the polarity, man? True resistance. Now this is the transistor. First I need to read the number, the PNP or NPN, and I need to show my multimeter. Okay. First I need to number, but I am not reading a number. I cannot read a number, so I need to check with multimeter. Okay, I think this is the pin PNP. That's okay. Now I need to check this. We have a PNP, true continuity. Now I need to check this. We have a PNP. Okay, PNP true resistance. Then why? Okay, here we have a 500 ohm resistance. Need to check, but first I need to check this NPN transistor. This is the NPN 6. It's okay. True continuity, true continuity, true continuity, true continuity, true continuity. And after that, we need to check one more. True continuity, true continuity. Okay, after that we need to check the 500 ohm resistor. Here we have, first I need to find, okay, the marking code is 68A, 68A. Okay, this is the 500 ohm resistor. True resistance, that's okay, one. Here we have another second true resistance, and here we have third true resistance. It's okay. On the 500 ohm resistor is okay, and still we are not receiving. Okay, after that we need to check the voltages on this capacitors, and this PC817, because the microcontroller are operating this PC817, and after that they can provide a positive voltages for this gate drive voltages. Okay, so now I need to check this PC817 continuity first. And after that, first I need to check this PC817. True continuity, true continuity, true continuity. Now I need to check about the voltages this capacitors. We are receiving the voltages per drive. These two MOSFETs are not. And first, the laser focus I need to find pin 1. This pin 1 is connect with this diode and this transistor. Okay, and this is the capacitor of this. Okay, in the middle we need to check, and after that we need to check pin 5. 1 2 3 4 5. This 5 number MOSFET gate drive pin is connected with this transistor. Okay, and this capacitor, we need to have a voltages on this first. So first I need to apply voltages and turn off the inverter, and after that I need to turn on. Okay, and then I need to check the voltages on this capacitor. Okay, I turn on the inverter, and we need to have every time a voltages in the fault mode. Okay, here we have 10 voltages per drive. Here we have 10 voltages. This voltages is enough to run this MOSFETs. Okay, now we need to check the control drive from MCU. So now we need to check this, This pin number 1 is connected with this diode and this transistor, and this capacitor and this optocoupler is connected for this transistor and this optocoupler. I need first to confirm. Connect this optocoupler this is confirmed to drive this pin 1. Okay, so first I need to check the voltages on autocoupler from microcontroller. Okay, so first I need to keep the multimeter probe on the PC817 LED side and not cathode side. Okay, and now I need to turn on. If we receive some voltages on these pins, and this voltage is coming from microcontroller. Okay, we are receiving the drive voltages to drive this PC817 from microcontroller. After that I need to check this another. Okay, we are receiving the voltages from microcontroller, and now I need to check this one another. Wait a minute. Can I? Okay. I have. Okay, first I need. Sometime we have a true resistance with multimeter, but our transistor is not working. So first I need to check this. This transistor is NPN or PNP. If we have a PNP, so we need to have here continuity and here continuity. So it means this is the PNP, and if this is the PNP, we need to have, it's okay. We need to have, it's okay, this is the PNP. Now I need to check this, it's okay. I'm replacing this 3 at a time to save time. Sometime we have a true resistance of transistor, but transistor are not working in the real time. Okay, so now I am replacing this SMD PNP transistor and keeping on the side. This is the PNP. It's okay. Now I need to replace. First I need to provide some solder here. Now I need to replace the PNP transistors. PNP transistors. Okay. Okay. And the good thing is that you need to have this extra little drive card to replace quick and check. Okay, but now I have not this card, so I need to do this. First I was had, but now I can repair this, so I am repairing this. But the person make me mad to repair this thing. That's okay. Now I need to check. I think we have issue. Not at the fault now. Our inverter is now ready. Now I need to check the output voltages first. Two hundred and 230 we need on this side, but the real thing is that to check the pure AC voltages. Okay, this is better than for this feature from this multimeter Fluke 179. Okay, we have on this side, and now we need to reverse the polarity. It's okay. Pure AC voltages we have now. It's okay. And now we need to check the charging voltages. And now we need to check this transistor. Why we have a true value in the board, and why when we replace this transistor our issue is solved. Okay, and I not replace this with the Fluke. Okay, I trace the fault first, and after that I remove this transistor. Okay, you cannot repair this with Flukes. So this is the PNP transistor. So here we need to have a continuity. We have, and here we need to have. We have, okay. And now we need to check this other hand. We have continuity. We have continuity. here we have now we need, if you want to check this transistor, so you need to place this and apply a voltages on the emitter gate and collector, and after that you can check. Okay, but we was had issue finally in this transistor, and I replaced the UC3843 true PWM modulator because this is not the true number. Okay, as you can see here, first here we was had a bad continuity right here, and also keep in the mind this is the true continuity of this charging section, 700 plus 750 plus ohm. Okay, and for this side we need to have 1.6 continuity. This is the important continuity for this charging section. Okay, so our inverter is now ready, but now I just need to check the, and from where I solve this problem, I need to some schematics. I need to draw some schematics for you. Okay, I solve this issue with this knowledge. Okay, here we have a 4N channel MOSFETs. Okay, 4N channel MOSFETs. One, two, three, 1, 2, 3, 1, 2, 3, 1, 2, 3. Get, drain, source. Get, drain, source. Get, drain, source. This is my second time to drawing this circuit. Here we have a 450 volt capacitor, okay, and 47 UF. This is the negative and this is the positive. Okay, the positive is coming or connected with this drain. Okay, with this drain and with this drain. Okay, and the negative connected with this source, with this source and with this source. Okay, so how I found this issue? First I keep the multimeter positive probe. Okay, first I check the voltage on the capacitor. We was received the voltage as on this capacitor. First I keep the multimeter positive probe on the capacitor positive and set my multimeter on DC voltages, and when I keep the negative for this source, so sorry, for this drain, positive here I was keep, and here coming negative. Okay, so you need to keep your multimeter negative on this drain. Okay, and when you turn on your inverter and you receive the negative voltage from this MOSFET, so you need to receive a 290 voltages on this drain, and after that you need to turn off your inverter again and turn on restart, and first keep the multimeter negative, and you need to receive from here 290 voltages DC. Okay, after that you need to keep negative on your this capacitor, and you need to keep the positive probe on this source, and you need to have receive at a 290 volts DC, and after that you need to check this another. Okay, from where I found I was not receive here positive and here positive. Okay, so I was no, we have issue in this two MOSFET. Okay, so I found the issue from this section and with this knowledge. Okay, and how this inverter can provide AC voltages from DC, because here we have a DC voltages. Okay, DC voltages. Now I am guiding you how it's possible. We are receiving AC voltages. Our microcontroller is turning on at a time once this MOSFET, for example, this source, for example, when microcontroller provide a gate drive voltages for this MOSFET, and one for this MOSFET. Okay, not providing all control drive at a time. A microcontroller apply a voltages for this MOSFET. So here we receive on this time positive. Okay, and this is repeating 50 times in 1 second. Okay, because you can call the 50 hertz frequency of this. Okay, and when the microcontroller apply the voltages, drive voltages on this MOSFET, so here we have a negative. Okay, here we have a negative, so we receive on this side negative and this side positive. Now the time to reverse this, to off this MOSFET. Now the microcontroller turning off this two MOSFET, turning off. Okay, and on this, if we receive a PWM for this MOSFET, so on this time this AC output is connected like this. So now we receive a positive from this MOSFET. Okay, and this is connected with this AC output. Okay, so I need to write this on blue. AC out. Okay, now the microcontroller off this and on this and this, and here we have a negative. Okay, so this negative is coming like this. Okay, and I need to do a jumper. Okay, here now we receive a negative, because here we have a negative and the microcontroller switch the gate. Okay, so here we receive in this time this point negative, and for this point positive, and when they off again and turn on this MOSFET, now turn off. So this is repeating in the 50 times in 1 second, so you can call this 50 hertz frequency. And this is the method of converting the DC voltages to AC. Okay, and you can create this PWM with SG3525, and you can get a 50 hertz and 50% duty cycles but you can get a full square wave, okay, like this square wave, because the SG3525 is PWM square wave modulator, so you can get a square wave AC voltages, okay. And this is the modified sine wave like this, this is the modified sine wave, okay. This is the modified sine wave, and you can create a square wave with this method, and you can make the AC voltages from DC with this method, okay. So we troubleshoot a fault with the help of this schematics and this circuit, okay. And I am also sharing with you some special things, okay. So now I need to just check the charging voltages. I need to connect the cooling fan, and I pass in the exam. Okay, first I provide how much voltage is. Okay. Okay, we are receiving. Now I am removing the power supply, and we are receiving 13.8 volt fluid charging, okay, fluid charging voltage. Now our inverter is completely okay. To you, brother. I need to read some comments. And on what time you comment, man, and I was very busy and this thing. And sorry for your comments for Red Libra, multi-tube, cherry UPS, Shrey UPS. Brother, what are you doing? Oh man, 1P, 2F. Yes, man, I know about the 1P as NPN and the 2F as PNP, but I can't read, okay, no any number, so I can check with multimeter, not to know the numbers. I can read with the multimeter this transistor is PNP or NPN. But thank you for your suggestion. And multi-tube, first I need to check your channel. What's about, man? Go to channel. You have a channel or not, man? Channel activity, multi-tube. What's mean? I think you don't have a channel activity. I am doing here, man, some special works. This is very beautiful work, but a person work first from me, so it's difficult for me because they remove everything and install a wrong number of PWM and they install a jumper like this here, fused wire, so they install quickly like this, and I remove this and I proper they install like this. This is not good, man. And how are you, man? And from where? I need to remove my cell phone. Okay, brother. I think you leave the live. You leave the live. But I have some friends more. Anyone have a question about PWM modulation, like a DC to DC boost section, or DC to DC boost converter, or DC to DC buck converter, or step down converter? If anyone have issue in this project, so you can ask from me, and I can help you. And buck boost converter, or step up and step down converters also, if you need. And if you want to draw schematics for step up and step down converter, so now I can draw for you how you can create your own PWM pulse wide modulation. Anyone have a question about hybrid inverters, charging section, or backup mode, or VM3 or VM2, if or soft start? People are watching me and not giving a suggestion or opinions. Man, now I have just 2 bars in my battery, and the third bar is charging, and I forget yesterday to charge. And this is my bench I cleaned today, and I install some more lights. And yesterday night I installed here this lights, very good video quality. I was issue, but not good for my eyes, so I remove this again and install again there. And look at the video quality. This is the halogen 500 watts, and when I turn off, what vision is good, man? I think this vision is good, but when I keep the board on another side, so after that we have a very high reflection. But now I can use both. This is the 4000K temperature light, and this is very good for video, as you can see. Now I need to zoom. This is very good light for this. Okay, and now I need to come again live for the breaker was trapped. I need to replace this breaker, because I installed this just for shop, not for workshop. But after the shop, I create a workshop in my shop, and first I was a shopkeeper, and I have a ready system to make me again a shopkeeper, because I have a workshop on main famous road. As you can see, a very crowd area, but I am loving with this. I love with these things. I am not liking selling the products. And thank you for everyone. And multi-tube, man. Oh, join 42 subscriber. Then why your channel is not showing me man. It's moderator. Okay, I can find you on YouTube search. It's okay. Take care. Goodbye, friends, and I need to come live again with another topic. Take care. Bye.